Hello, this is not your chem tutor, and in this video, we will talk about a combination of two topics in chemistry, the ideal gas law and reaction stoichiometry. And as usual, like in my other videos, I included examples so we can practice some calculations. In this video, we will not be learning a new topic or a new concept in chemistry because as what I've said, we will just be combining topics which you should have previously learned. So before you continue this video, make sure that you already understood these three topics. Number one, the ideal gas equation. Number two, mole concept. And number three, reaction stoichiometry. I will not go into detail about these topics because I made separate videos on these topics. So if you want to check my videos on the ideal gas equation, mole concept, and reaction stoichiometry, then you can check the description box for the links. So in this video, we will actually proceed right away to the examples. And as we go along each example, you will see a pattern or a technique in solving problems involving ideal gas law and stoichiometry. Okay? So for example 1, hydrogen gas and chlorine gas react to form hydrogen chloride in the following reaction. So the reaction is given below. If 2.50 moles of H2 react with excess Cl2 in a 2-liter vessel, what will be the pressure exerted by HCl at 25 degrees Celsius? So in this problem, we are given 2.50 moles of hydrogen gas. The first step in solving this problem is the stoichiometry part. Okay, we are given 2.50 moles of our reactant, H2. We will convert this into moles of the product. And our product is HCl. So we will use stoichiometry. So the given is 2.50 moles of H2. Then look at the balance equation. According to the balance equation, 1 mole of H2 forms 2 moles of HCl. So you plug that. 1 mole of H2 forms 2 moles of HCl. So H2 cancels out, moles of H2 cancels out. Now you are left with moles of HCl. And if you solve this, 2.50 times 2, this is equal to 5 moles of HCl. So the reaction produces 5 moles of HCl. And then the question says, what will be the pressure exerted by HCl? So we proceed to the second part of the solution, the ideal gas law. So ideal gas we know is PV equals nRT. But the question is asking for pressure, so we rearrange the equation to solve for pressure. And if you rearrange the equation, it becomes pressure equal to nRT divided by V. So this will now be our equation for pressure. And then we substitute the values. The question is asking for the pressure of HCl. So the pressure of HCl is equal to, we know that N stands for moles. So the moles of HCl, which we got in the first part, is 5 moles. So you put there 5 moles of HCl. We know that R is the gas constant, 0.0821 liter atmosphere per mole Kelvin. T is temperature in Kelvin. And according to the problem, if you read the last sentence, it says the temperature is 25 degrees Celsius. So we need to convert first 25 degrees Celsius into Kelvin. And how do we do that? We add 273.15. So 25 plus 273.15, that is equal to 298.15, and this will be in Kelvin. So this will be our temperature. So you put that into your equation, 298.15 Kelvin, divided by the volume, which is also given in the problem. It says here 2 liters. So divided by 2 liters. So let's see how the units will cancel out. The moles will cancel, liters will cancel, and Kelvin will cancel. So we are left with the unit ATM, which is the unit for pressure. So the unit is ATM. Now grab your calculator and let's solve for the pressure. 5 times 0.0821 times 298.15 divided by 2. The pressure is approximately 61.2 atm. And this is the answer to example 1. Okay, so for example 2, when solid potassium is placed in water, a vigorous reaction occurs. The reaction is as follows. If 5 grams of potassium react completely with excess amount of water, what volume does hydrogen gas occupy at STP? So the problem gives us 5 grams of potassium, and we know that potassium is a reactant according to the reaction above. When you are given grams, whenever you are given grams, the very first thing that must come into your mind is to convert that into moles. Because we cannot use grams in stoichiometry. We always work with moles, right? So the very first step, the very first part in the solution is mole concept. So we will convert 5 grams of potassium into moles of potassium. So how do you do that? You need the molar mass of potassium. So grab your periodic table and look for the molar mass of potassium. So according to the periodic table, 1 mole of potassium is equivalent to 39.10 grams of potassium. So grams will cancel out. Now you have moles. And then you solve. 5 times 1 divided by 39.10, that is approximately equal to 0.128 moles of potassium. So now that you have the moles of potassium, you can proceed to the second part of the solution, which is the stoichiometry. So we just solved 0.128 moles of potassium. If you read the problem, the question asks, what volume does H2 occupy at STP? So the problem is concerned with H2. So we will convert moles of potassium into moles of H2. So looking at the reaction, the balanced chemical reaction, 1 mole of potassium produces 1 mole of H2. So it's a 1:1 ratio. So you put that in your solution, 1 mole of potassium produces 1 mole of H2. So moles of potassium will cancel out. Now you have moles of H2, which is equal to 0.128 moles of H2. Now that we have the moles of H2, we can move on to the third part of our solution, which is ideal gas law. Because the question is asking for the volume of H2. So again, the ideal gas equation is PV equals nRT. If you want to solve for the volume, you need to rearrange the equation. It becomes volume equals nRT over P. So the volume of hydrogen gas is equal to, again, N is the number of moles, which we just solved in step 2. It's 0.128 moles. R is the gas constant, 0.0821 liter atmosphere per mole Kelvin. T is the temperature. Now, when you read the problem, it does not explicitly give you the temperature, but it says here STP. At the very last part of the question, it says here STP. And what does STP mean? If you can recall, STP means standard temperature and pressure. And the standard temperature is 273.15 Kelvin, and the standard pressure is 1 atm. So this is what you mean by STP. So if you want to learn more about STP, you can check my separate video. I made one, and you can check that using the link on the description box. So for the temperature, because the problem says STP, we will be using the standard temperature, which is 273.15 Kelvin. Divided by the pressure, since again it's STP, we will be using the standard pressure, which is 1 atm. So let's see how the units will cancel out. Moles will cancel, Kelvin will cancel, atm will cancel. So the remaining unit is liter, which is the unit for volume. So grab your calculator, 0.128 times 0.0821 times 273.15 divided by 1. This is approximately equal to 2.87 liters. And this is the answer to example 2. For example 3, when nitrogen gas reacts with hydrogen gas, gaseous ammonia forms as in the following reaction. So the balance reaction is given. If 1.40 liters of N2 reacts with 2 liters of H2, both at 0.900 atm and 303 Kelvin, what is the volume of ammonia produced at the same temperature and pressure? So the problem gives us the volumes of the reactants. So we have 1.40 liters of N2 and then 2 liters of H2. It also gives us the pressure, 0.900 atm, and the temperature, 303 Kelvin. So given these data, the first step in the solution is using the ideal gas law. So we will be solving for the moles of N2 and the moles of H2. So the ideal gas equation is PV equals nRT. If you rearrange the equation to solve for the moles, moles is equal to PV over RT. So let's solve first the moles of N2. So the pressure in the problem is 0.900 atm. The volume in the problem is, the volume of N2 is 1.40 liters. R is 0.0821. And T is the temperature, which is 303 Kelvin. So let's see how the units will cancel out. ATM cancels, liter cancels, Kelvin cancels, so the unit is moles. And if we solve this in our calculator, let's type the numbers. 0.9 times 1.40 divided by 0.0821 times 303, that is approximately equal to 0.0507 moles of N2. And then let's do the same thing to solve for the moles of H2. Okay, so for the moles of H2, we have the pressure, same, 0.900 atm. The volume of H2 according to the problem is 2.00 liters divided by the gas constant, 0.0821 liter atmosphere per mole Kelvin. And the temperature is the same, 303 Kelvin. So the units will cancel out. So the remaining unit is moles. So moles of H2, if you solve this in your calculator, 0.900 times 2 divided by 0.0821 times 303, you will get 0.0724 moles of H2. So now that we have solved the moles of the individual reactants, we can proceed to the second part of the solution, which is stoichiometry. So we have two reactants, 0.0507 moles of N2 and 0.0724 moles of H2. So using the balance equation given to us in the problem, we will convert each reactant to product. So moles of N2, if we look at the balance reaction, 1 mole of N2 produces 2 moles of NH3. So you write that into your equation, 1 mole of N2, 2 moles of NH3. So the moles of N2 will cancel. So now you have moles of NH3. And if you solve this, 0.0507 times 2, this is equal to 0.1014 moles of NH3. And then let's move on to the second reactant. So according to the balance equation, the relationship of H2 and the product is 3 moles of H2 gives 2 moles of the product. So 3 moles of H2, 2 moles of NH3. So the moles of H2 will cancel out. Now we have moles of NH3. And if you solve this, 0.0724 times 2 divided by 3, this is approximately equal to 0.04827 moles of NH3. Now that we have solved the moles of the products using the moles of the reactants, we will now decide which is the theoretical yield. So you will compare your two answers, 0.1014 moles and 0.04827 moles. Remember the definition of the theoretical yield? The theoretical yield is the smaller amount of product that can be produced by the given reactant. I repeat, theoretical yield is the smaller amount of product that can be produced by the given reactant. So if you compare the two, which one is smaller? It will be 0.04827 moles. So your theoretical yield is 0.04827 moles of NH3. So we're done with step 2. And finally, step 3, if you read the question is asking, what is the volume of ammonia produced at the same temperature and pressure? So it's asking for volume, so we will again use the ideal gas equation or the ideal gas law. So if we rearrange the ideal gas law to solve for volume, volume is equal to nRT divided by P. So the volume of NH3 is equal to the moles of NH3 or N, that is the theoretical yield, 0.04827 moles. R is the gas constant, 0.0821 liter atmosphere per mole Kelvin. And T is the temperature, 303 Kelvin. Divided by the pressure, which is 0.900 atm. Let's see how the units will cancel. Moles will cancel. Kelvin will cancel. And then atm will cancel. So the remaining unit is liters, which is the unit for volume. So the volume of NH3, the unit is liters. And if you solve this, 0.04827 times 0.0821 times 303 divided by 0.900, this is equal to approximately 1.33 liters. And this is the answer to the question. For our final example, aluminum reacts with hydrochloric acid, forming hydrogen gas. How many grams of aluminum is needed to produce 10 liters of hydrogen gas at STP if the percent yield of the reaction is 35%? So according to the problem, you need to produce 10 liters of hydrogen gas at STP. Again, when you say STP, that's standard temperature and pressure. The standard temperature is 273.15 Kelvin, and the standard pressure is 1 atm. Since we are given volume and temperature and pressure, the first part of the solution is actually to use the ideal gas law. Okay, so we will solve for the moles of hydrogen gas. So when you rearrange the ideal gas equation, so PV equals nRT. If you solve for N, the equation becomes N is equal to PV over RT. So let's solve for the moles of H2. The pressure is the standard pressure, which is 1 atm. Volume of H2 according to the problem is 10 liters. Divided by R, that's 0.0821 liter atmosphere per mole Kelvin. And then T is the temperature. The standard temperature is 273.15 Kelvin. So atm will cancel, liters will cancel, Kelvin will cancel. So we are left with moles. So the moles of H2, if we solve this using our calculator, we have 1 times 10 divided by 0.0821 times 273.15. You will get approximately 0.446 moles of H2. According to the problem, this is the amount of H2 that you need to produce So in other words, this one is your actual moles of H2. And then the problem says the percent yield of the reaction is 35%. So this will be part 2 of our solution. We will use the equation for percent yield. If you can remember, percent yield is equal to actual divided by theoretical amount times 100. So according to the problem, the percent yield is 35.0%. So you put there 35.0. This is equal to the actual yield, which we just solved in step 1. That's 0.446 moles divided by theoretical yield times 100. If you divide both sides of the equation by 100, the left side is 35 divided by 100. That is equal to 0.35. And on the right side, 100 will cancel. So you're left with 0.446 moles divided by the theoretical amount or theoretical yield. If you want to solve for the theoretical yield, you will rearrange the equation. And the equation becomes theoretical yield is equal to 0.446 moles divided by 0.35. If you compute that, the theoretical yield 0.446 divided by 0.35, that is approximately 1.27 moles. So the theoretical yield of hydrogen gas is 1.27 moles of H2. So this one is your theoretical yield. Now that we have the theoretical yield for H2, we will move on to our final step in our calculation, which is stoichiometry. So our theoretical yield of H2 is 1.27 moles of H2. According to the balance equation, what is the relationship of H2 and aluminum? Because the question is asking for how many grams of aluminum. So let's look at the relationship of H2 and aluminum. 3H2, 2 aluminum. So you put that into your equation. 3 moles of H2 on the bottom, and then 2 moles of aluminum on top. So the moles of H2 will cancel. Now we have moles of aluminum. And if you solve this, 1.27 times 2 divided by 3, this is approximately 0.847 moles of aluminum. Now that we have the moles of aluminum, the question is asking for grams of aluminum. So how do we convert moles to grams? We will use the molar mass of aluminum. So there's actually an additional and final step, which is your mole concept. So we will convert 0.847 moles of aluminum. So the molar mass of aluminum is 26.98. grams per mole. So you put that into your equation. 1 mole of aluminum is equivalent to 26.98 grams of aluminum. So the moles of aluminum will cancel. Now you have grams of aluminum. And then you solve this using your calculator. 0.847 times 26.98 divided by 1. This is approximately equal to 22.9 grams of aluminum. And this is the final answer for example 4.